In the last video, we focused purely on calculating derivatives. Our goal back then was straightforward, mastering the computation skills. Think of it like this. I might not visualize the graphs yet. I might not see the big picture of why derivatives matter, but I can find the derivative of any function you give me. And based on your practice work, you built a really solid foundation with those calculations. Today, we are shifting focus completely. Forget about the calculations for now. We are diving into graphs, specifically exploring the connections between function f, its first derivative f prime, and the second derivative f double prime. The key skill we are developing is this. If I show you the graph of just one of these three, say f prime, can you visualize what the graph of f and f double prime should look like? Mastering this visual connection is exactly what we will achieve by the end of this video. Before we dive in, a quick heads up for exam takers. If you are preparing for A-level pure math, feel free to skip the video. The f prime, f double prime graph links do not appear on your exams. However, if you are preparing for AP calculus, AB or BC, this is gold. Mastering the graphs can unlock over 10% of your AP exam score. Keep in mind that on the AP scale, getting 70% correct already means a solid 5. If you are caring about the UK versus US exam design difference, that's a fun cultural tangent we will save for another day. Anyway, for AP warriors, the next segment demands 100% attention. All right, let's build our ultimate graph decoding chart. Understand this once, and the exam questions become pattern matching games. First, let's connect f and f prime. Where the original function f is increasing, its derivative f prime must be positive. Why? Remember, f prime is the slope of a tangent line. If the function f climbs uphill, slopes must be positive. Where f is decreasing, f prime is negative for the same reason. Downhill slopes are negative. And where f has a flat tangent, that's where f prime is 0. Straightforward, right? Next, we use the same logic to link f prime's trend and f double prime's sign. Increasing matches positive, horizontal tangent matches 0, and decreasing matches negative. The critical insight, linking f's shape to f prime's trend. What happens when f prime is increasing? Imagine tangent lines evolve. In one scenario, a horizontal tangent gradually tilts upward and steepens as x increases. Slopes shift from 0 to a small positive to large positive. In another scenario, a steep downhill slope becomes less steep, then flattens. Both scenarios make the curve bend upward. We call these concave up. Concave up. Being able to hold water means concave up. What about f prime is decreasing? Tangent transition as x increases from uphill slope to flattens to downhill slope. This bends the curve downward. Compute down. Shape that spills water is compute down. At last, the points where f changes concavity, we call them points of inflection. Let me finish the writing. Points of inflection. Finish the last cell. You've got the decoder written. Please ignore this cell in the table. My apologies to my OCD friends. Now, in AP past papers, College Board loves throwing this exact question. Here is the graph of f prime with 5 critical x values: A, B, C, D, and E. The question would ask, where does f have a relative minimum? That is, as y value is smaller than its neighbors. First, we need to avoid the naive approach. Pick the lowest point we see. They showed us the graph of f prime, but asked about f, so D is clearly a distractor. What we should do is sampling matching. Relative minimum means flat tangent line plus concave up. So we just look for 0 plus increase in the graph of f prime. 0 and increase in the graph of f prime. And the answer A and E jump out. You surely can use this table flexibly. Relative minimum also means turning from decreasing to increasing, turning from decreasing to increasing. So I'll look for the point where f prime turns from negative to positive, turns from negative to positive, or negative to positive, negative to positive. That also solves the problem. Now, let's use the same diagram to find the local maximum or relative maximum. Relative maximum means concave down plus horizontal tangent line. So we just look for decrease and 0 in the graph of f prime. Then we find the correct answer C. It's also turned from positive to negative of f prime, corresponding to the f turn from increasing to decreasing. Now, let me make the clean table, which can help us to correct the code. Now, let's crush real questions from 2012 Calculus AB exam. And I will prove that 10% claim we mentioned from the beginning of this video. First, let's check question 76. The graph of f is shown. and we need to find where the f prime is both positive and increasing. F prime positive and increasing match where f is both increasing and concave up. So we need to find where f is increasing and concave up. Then E it is. Pretty easy, right? Then question 85. In this question, we need to find the local maximum of f based on the graph of f prime. The last row of our chart tells us that the absolute maximum, the relative maximum, not absolute, sorry, the local maximum, relative maximum of f matches the prime changing point of f prime. So C it is. The next question is question 87. This time, f double prime is shown, and we need to find where f is concave down. Where f concave down matches where f double prime is negative. So double prime negative, and we know the answer is E. Then let's check back. Question 80. This time we need to justify 3 statements and check which of the following statements must be true. Number 1. We need to find where f has a relative minimum. So f relative minimum matches f prime's sign changing point. F prime's sign changing point at x is equal to -3. So statement 1 is correct. Number 2. Point of inflection of f matches where f prime changes trend. That means we need to find where f prime turn from increasing to decreasing, or turn from decreasing to increasing, or where f has a flat horizontal. In this case, that x is equal to 0. So statement 2 is incorrect. Number 3. We need to find where f is concave down. F concave down matches f prime decreasing. F prime decreasing. And the statement 3 gives the correct interval. So E is the correct answer. Now we have crushed 4 MCQs in one paper. Is that all? Of course not. Let me first share a tip and then keep digging. I will type it here. Whenever a calculator allowed question shows a monster function, that is a very sophisticated function, the uglier the formula, the easier the way. Why? Because a sophisticated function means no computation required at all, since the exam gives you only 2 to 3 minutes for each question. So knowing the formula means knowing the graph. Then let's check question 82. Let me cut these two first. Okay, now let's check question 82. I will open the decimals. In this question, we know the formula. That's how we know the graph. Let me do the input. Okay, decimals is a very helpful tool. Then we can do the question as we did before, where f has a local maximum, matches where f prime turns from positive to negative. The graph of f prime turns from positive to negative. Decimals will tell us C is the correct answer. At last, question 84 has the similar setting. I'll shrink myself. This time, we have the function, and the function is not typical at all. That's why this question must be very easy. We have the formula, so we have the graph. From 2025, decimals is allowed in the exam. That's pretty good news. You do not need to buy the very expensive calculator TI-84, TI Inspire, or etc. Okay, now we have the formula of f prime, then we have the graph of f prime. This time, f concave down. F concave down matches where f prime is decreasing, f prime decreasing. And we can find that 0 to 1, negative 1.5 to negative 1. And D is the correct answer. After you truly master the graph decoding chart we made, you can do more than the questions want. Let me use this diagram as an example. We know that the trend of f corresponds to the sign of f prime. The second rule tells us that the shape of f corresponds to the trend of f prime, corresponding to the sign of f double prime. Use this simple rule. When we check the graph of f prime from left to right, we can see that let's check the sign of the f diagram first. It goes from positive to negative to positive to negative to positive. Then the graph of f must be increasing, decreasing, increasing, decreasing, increasing. And then when we check the trend of f prime, it goes from decreasing to increasing to decreasing to increasing. That tells us that the shape of f must be down, up, down, up, down, up, down, up. At last, the graph of f, we almost find every detail of the graph of f. based on the graph of f(h). Beyond the 6 MCQs we crushed, one free response question, FRQ, also tests F-prime graph analysis. Half of this FRQ question surrenders to our chart. The free response question's second half requires integral calculus, so we will dismantle it in a dedicated video in the future. Anyway, we have nailed over 10% of the raw scores in AP Calculus exam in this short video.